This is the cat that unplugged my keyboard. And this is the keyboard she unplugged. Bad cat. Hello, and welcome to day 2 of Evolvio. Last time, I showed the basic actions each creature can do, and I used the keyboard to control them. But I also suggested that neural networks could also be used to control the creatures. In this video, I'll show you what those neural networks look like. So for now, we can turn off keyboard control and go into brain control, which means that they'll now be controlled by their own brains rather than me. And when we do that, we can see that the creatures start moving on their own. So we can click on any of these creatures to see what they're thinking behind the scenes. Let's take Ratasri. Oh, Ratasri just died, never mind. Let's go with a slightly bigger creature. Nregisa. So this rectangle right here is the creature's brain. The inputs are on the left side, and the outputs are on the right side. There's about 13 inputs and about 13 outputs, as well as a hidden layer in between. Before I explain how the inputs connect to the outputs, let me just go over what all the inputs are. So, anything that starts with a V stands for vision. V angle and V dist just mean the angle of where it's looking, as well as the distance to the object it's looking at. Red, green, and blue correspond to the RGB values of the color the creature is currently looking at. Now, none of these creatures, okay, maybe a few up here. So this creature you can see is looking slightly to the right of itself and is able to record the RGB values of where that X currently is. So those are the first 5 inputs. Temperature is just what's on the thermometer at the exact moment. Pretty simple. Size is the size of the object, divided by 100, so 100 yum, which is the minimum, returns 1. Age is age in years. Para V means the velocity parallel to the direction it's facing. Perp V is velocity perpendicular to the direction it's facing. Rot V is the rotation velocity. And then we have memory and constant. Memory just means that whatever is outputted in memory here will be fed back into memory again, which is, oh, it just died, which is helpful to store information that can't be sensed with your senses later. But I don't think creatures will be using that for a long time. It takes a lot of evolution before anything advanced enough to require memory will appear. And then const always returns 1, which is very important, and I'll explain why later. Another thing I want to mention is that I want this simulator to be realistic, meaning that creatures should not be able to sense anything you wouldn't expect a real creature in real life to be able to sense. So for example, I was thinking of giving creatures an X and a Y sensor that could tell it what its X and Y coordinates are. But then I was thinking, if you grabbed a human off the street and placed them in a forest or something and then asked them, what's your latitude or longitude? They'd have no idea. So you can't expect creatures to know that either. However, the devil's advocate might argue creatures can tell their latitude by measuring temperature or the magnetic fields or something, but they're not really directly measuring latitude, and that's really complex anyway. So these creatures are quite simple. They should not be able to know their X and Y coordinates. And likewise, they also should not be able to know their rotation, because just like humans, you can't really tell north, east, south, west super easily. So as you can see, all these inputs are things that you can tell just by easily looking at the world around you. Now the outputs were just everything I showed you in the last video. V angle and V dist are just controlling its vision. B red, B green, B blue is just controlling the color of its body. Accelerate just means going forward and backward. Turn means turning. Eat, fight, birth, all makes sense. And of course negative eating is vomiting, which they can do as well. And then we've got filler, which does absolutely nothing. Memory, like what I said, if anything gets inputted here, it gets put back into the left side. And then const, which is also important, and I'll explain why soon. Now let's go over how the brain connects the input to the output. So all the input nodes, is pretty clear how they get their numbers, right? Now the hidden layer, what it's going to do is each node is going to, oh my god, each node is going to look at every single node in the column to the left of it and multiply it by a certain weight. You can see the weight of each connection by how dark or light the line is. After multiplying all the inputs by those weights, it sums them together to get a master value, and then just to make it a yes or no question, it puts it through a sigmoid function, which limits the value to between 0 and 1. And that produces the output for all the nodes in the hidden layer. Now the next layer over, the output layer, does the exact same thing, but with a hidden layer as the input. And that's pretty much all there is to it, except for one thing. The output, oh my god, the output layer does not put it through a sigmoid function because there are some outputs, meaning actions, that I do want creatures to be able to do with a force of more than 1 or less than 0. For example, you should be able to turn backwards, so turning often needs to be negative. So no sigmoid for the right side. Now I'm sure you're all eager to see what happens to these creatures after hundreds or thousands of years of evolution, but before that, I want to talk about a really important feature of evolution. So to do that, I'm going to stop brain control and go back into keyboard mode. Oh wow, they're all dead corpses again. So let's take over Dro now. So this has to do with reproduction, which is pretty crucial to evolution, don't you think? I mean, without reproduction, you can't evolve at all. So like I showed you in the last video, producing offspring can be really simple. As long as you're larger than 2 times the minimum body size, you can just press B and you'll produce a child that's slightly mutated from you. By the way, all the weights of the axons between neurons in the brain, that's what children inherit from their parents. And it's slightly mutated so that evolution happens. But since 9 out of 10 geneticists agree that sexual reproduction is more beneficial to the whole group over asexual reproduction, I decided if I want this evolution simulator to be as good as possible, then I should add sexual reproduction. However, I don't want to have 2 different functions for those 2 different actions because that's just really confusing. So, how can you combine your genes with another creature to produce an offspring that's more diverse? Well, here's how. Do you remember the fighting radius that is double your body radius? Well, that's also very important for if you want to have children with someone else. If you have a baby and someone else is inside that intimate radius, if you press B, you will actually have a child together, and you can see the color is like a mix of us. In addition, the name is a combination, like a portmanteau of 2. So we have Dro, Leril Tato, and then Dinitata with a mutation also. So that's pretty cool. Oh, the baby just died. Oh, and I just died as well. The reason I like this method of reproduction is that it gives creatures the option to reproduce sexually or asexually. There's really no hard line in between the 2. And then another thing is, I don't want to limit these creatures at all, so let's create this scenario. If we have 3 parents all within the radius I was talking about, and then we press B, we can actually produce a child with 3 parents. And the genes of all 3 parents will combine into the child. So that's like 3-way production. Doesn't really happen in the human race, but it easily could. And of course it's unlimited, so that also goes up to 4, 5, 6, and so on. So yeah, I think I've got a pretty cool mechanism for reproducing. However, after watching my evolution simulator for a few minutes, I quickly noticed a problem that needed to be addressed. See, when 2 creatures are about to have a baby together, all it takes is for one creature to decide to have a baby and, press B, and both together will produce the child, right? So if we're thinking from the neural network sense, only one of the 2 creatures needs to have a value of greater than 0 to have a baby, because in the neural network, if the birth number right here is positive, then you will have a baby if you can. If it's negative, you will not. In other words, it only takes one parent's consent to give birth to a baby. Another thing I need to mention is that when the computer is trying to figure out whether these creatures can even have a baby, this is how it does it. So the white inner radius right here is the outline of the minimum possible survival size. So anything outside that radius you can think of as extra fat. You can think of that as available energy, not necessary for life. And that's stuff that you're willing to give up for a child, right? So it adds up all this excessive fat and sees if that adds up to more than the minimum baby size, and if it is, then it produces the baby, taking energy proportionally from how much each parent has. So the bigger parent will give more mass away. You can see I shrunk a lot, whereas Sim did not shrink that much to produce the child. So it's a proportional fat giving system. However, it is possible for the smaller parent to be the initiator, the one who actually brings about the birth, while the larger parent doesn't really consent and ends up giving most of the fat. That is a problem for if creatures get really, really big just because they like eating a lot, and they want to stay that way, but then another creature comes around and ruins that for them. Check out this clip I recorded earlier of me witnessing this bug. Look at Go. Go is pretty big, but look at that, it just explodes. Why did Go explode? Well, it didn't really explode, but nearby creatures just said, hey, have a baby with me, and Go really couldn't refuse. And doing that frame after frame after frame means that dozens of babies can be produced in a very short time. because of just one really big creature. Now, there weren't dozens this time, but there have been dozens in more extreme cases. This is just unacceptable. I mean, you could just expect creatures to learn to avoid any other creatures they don't want to have babies with, to avoid risking losing all of their precious fat. However, I felt like this was unrealistic, because if there's a bunch of species who are all unaggressive toward each other, they should be able to coexist at close distances without having to fear that half of their mass would be instantly removed just because some other species wanted to get a little action. Also, do you remember fighting? Killing a humongous creature through fighting... Oh, get this out of the way. Killing a humongous creature through fighting should be a long, arduous ordeal. See how long this is taking? This genetic theft feels like cheating to get the same result. Even though the whale's fat isn't directly hitting the floor, I still feel like this despicable atrocity needs to be stopped at once. So I needed a solution, and I think I came up with one that's pretty simple. All you have to do is, when you're controlled by your brain, if your birth value is greater than 0, that means you'll try to have a baby. If you're not big enough, you won't, but this number just means that you will try as hard as possible. Now here's what's different. If that value is between -1 and 0, that means you're willing to have another baby if another creature comes up to you and does it, but without that initiator, nothing will happen. Now, if you're below -1, then regardless of whatever creatures are around you, you will not have a baby, no matter what. So this allows creatures to say no. Oh my god, this is getting weird. So this allows creatures to say no, but it does take a bit of evolution, since by default most values end up between -1 and 1. This will hopefully give creatures more options to play with, and more power to decide what they really want to do with their bodies. In the beginning, I expect we'll see more exploding large creatures like Go, but if these behemoths can learn, they'll soon know to turn this number really, really low. By the way, everyone, if you're wondering why the population is flatlining at 60 all the time, it's because I haven't maintaining population at 60, meaning that if the population ever goes below 60, the computer will randomly generate a creature at a random location, just to make sure it stays at 60.